Alright guys, so this is a review. I'm gonna start all these reviews by going over which ones to put stars next to. So this was the day one review. So those of you who were in class Monday, you saw this review already when I presented it in class. So stars for this one, I need you to do these two problems right here. And on this one here, you're going to do the entire sheet, so stars next to every single one of these problems. Now, for these guys, you need to graph them. Then you can answer the bounded and not bounded stuff. So, put these equations here into the calculator and then get me the answers. Okay, so, and moving forward, you had to do number 9, number 10, these two right here. And then number 18 through number 23, so these right here. Okay, so those are the stars for day one review, and I'm going to continue now with the notes. So if you were in class, you already saw these. Again, this is the breakdown of the test. And magic number here, guys. $17 questions, that's what you need. So that's what I need from y'all. Alright. Alright, so first problem here is something where they're asking me, here they're asking for false. I mean, on the actual test they could ask you for which one of these statements is true, but they'll give you a graph, something like this, and maybe like a couple of things to look at. And so first thing is, what's odd symmetry? And so like I mentioned in class, guys, even symmetry is when it's even, or when it looks the same on both sides of the y-axis. So even if I had this shape over here, if I look at the y-axis, it doesn't look the same on both sides. So this, even though it's still a U shape, this is not even. Okay, and I know they're asking for odd over here, but I just want to tell you what even is just in case. Okay, so odd, something that looks like this. So really what I'm asking is, if I were to flip this 90 degrees, it'd look like that. And then I flip it another 90 degrees. Well, now I have the original shape again. Okay, so this is odd. So if I flip it twice, will it give me the original shape? Now, what's important about the odds, guys, they'll have some sort of center point right here. So again, if I start it over here, the center point over here, if I flip it once and then flip it twice, it's not in the same spot. So that's what's important about this one. So right here, this looks like to be my center point. And I can tell it's not even because it doesn't look the same right here. But it's not odd either because this point would have been right here. Okay, so this one right here is false. Okay, bounded above or below. So bounded means that it has to have a stopping point, either a low point or a high point. And I can see here I have an arrow. So this right here is not bounded below or above. Okay, so this one is false. So just to give a little bit of context, this one right here, this is a low point. So this right here would be bounded below. And this one right here, if this was a point, well then they would be bounded above. Okay, also asymptotes, those are also bounded whichever way they are. So that's what bounded is. Okay, and do I have any relative extremas? So remember this word right here, this is either looking for a max or a min, and local or relative means not the highest point of the whole thing. So this one right here, I see that I have, right here I have a min, and this is local because the graph keeps going on, so there's lower points than this. And I would say it happens at x equals a, right here. This one right here is a max, and this keeps going up forever and ever and ever. So that would be local, not absolute. And this would be at x equals b. So is this one true? Yeah, this one's true. Okay, so again, guys, over here, because this is the lowest point of the whole graph, I would say that this is a min, but this would be a absolute min. Okay. Okay, so just a little bit of context, what local and absolute are. So, so here they're telling me h of x is this equation right here. So which of the following functions, f of x and g of x, if I did this, did f of g of x, would give me this equation here. Okay, so I'm trying to find, these are a bunch of answer choices, which one of these equations, or which one of these sets of equations will give me this. And what I'm asking is, let me plug the g equation into the f equation. So here, if I plug this g equation in here for x, well then now I don't see x, I need x minus 3 cubed. This does not look like that, so this is not the answer. If I plug this in for x, it will give me this right here. So that does not look like this, so not the equation. If I plug this in for x over here, well then, now it looks like that. That's what I'm looking for, so this is the answer. Okay, so, alright. So this one, guys, I went through this with y'all. So I told you to put these notes. This has to do with vertical movement or vertical shift, either up or down. C value has to do with horizontal shift, either to the left or to the right. B has to do with horizontal stretch or shrink. And here, guys, we're looking at the reciprocal. That's what it's actually doing, 1 over b. So, and this one over here is vertical stretch or shrink. And this one's a little bit more straightforward. So another thing to remember, if I have a negative in front of the A, this is reflect across the X, and the negative in front of the B means reflect across the Y. So if I'm looking over here, this is my A value, my B, I don't have a C, and this is D. So looking at this, first thing I would do is probably start here. So plus 4 means it shifts 4 up, and if I look at my answers, I mean, they all say shift 4 up, so I can't eliminate anything yet. Okay, I move on to A. This is a 2, and I know that vertically stretching or shrinking, so this is 2 stretch in the vertical direction, so I can get rid of answer D. Now B is where we're a little bit tricky. So first, let's deal with the negative. So negative in front of the B means reflect across the Y. So guys, I can get rid of answer C because of that. And B, I'm using the reciprocal, so 1 over B. So this is 1/3. I'm actually looking at 3 over 1. So this is stretching by 3. So the answer is B. Okay. So, moving forward, guys, this should be like an easy problem if you get something like this. Possible zeros. So here, this is just P divided by Q, where P is the last number, Q is the first one. So remember, I don't want 6 divided by 3, I want the factors of 6. So if I multiply 1 and 6, it gives me 6. If I multiply 2 and 3, it gives me 6. So those are the factors. And in the bottom, those are my factors. So I'm going to go through each one of these and divide by 1. So 1 divided by 1 is 1. 6 divided by 1 is 6. 2 divided by 1 is 2. 3 divided by 1 is 3. So okay, and when I come back through these, now I'm going to pretend the 1's not there. 1 divided by 3 is 1/3. 6 divided by 3 is 2, but it's already part of my list. I don't have to write it twice. 2 divided by 3 is 2/3. And 3 divided by 3 is 1, which I already have part of my list. I don't have to write it twice. So this one is answer C. So, when I'm dealing with asymptotes here, so there's a couple things here. So one, if you have a denominator, if it doesn't cancel at least, then I'm going to have a vertical asymptote. So here, just before I even start here, I have a vertical asymptote. Okay, so I'm going to go ahead and get rid of this answer choice because this one says I don't. Okay, and the way I would figure that out, where it's actually happening, I mean, if I look at these answer choices, they all say x equals 2, the remaining ones. But the way I would figure it out, if they were different, is set it equal, the denominator equal to 0. Okay? Now, the other asymptotes I could have is either a horizontal asymptote or a slant, or what we call an oblique asymptote. These two right here, you either have one or the other. You don't have both. Okay, so what you're gonna do is look at your powers up here. Okay, so the highest power I have up here is a 2. The highest power I have up here is a 1. Right? They don't write it, so this is a 1. Okay, so this means something here. This over here I call N, and this one I call M. So when my N is bigger than M, okay, when it's bigger on the top than it is on the bottom, you're gonna have a slant or oblique asymptote. So here I can already tell I'm gonna have a slant asymptote, bigger on top than it is on the bottom. So I could, and if I have a slant asymptote, that means I don't have a horizontal. So I can get rid of this answer choice because look, it's telling me I have a horizontal. And it also tells me I don't have a slant, which is not true. This one tells me I also don't have a slant, okay? So that's also not true. So the answer is the last one. Now, horizontal asymptotes can happen the other way when it's bigger on the bottom than it is on the top. And in that case, it's always at y equals 0. Or when they're equal, so if I had a square up here and a square down here, then it would be the coefficients of the highest degree divided by each other. What I mean by that is, let's say that this said x squared minus 2 on the bottom, so then I would divide 2 by the number in front here is a 1, so 2 divided by 1 is 2. Okay, so I do have a slant asymptote because it's higher in the top than it is in the bottom. And had I had to solve for this actual point where it's happening, or this line, all I would have to do is divide the two polynomials. So here I take the coefficient in front, 2. Here's 1, so 2 divided by 1 is 2. Okay, here I have a square and here I have an x, so I'm missing an x. And now multiply 2x times x is 2x squared. 2x times negative 2 is negative 4x. And I switch the signs here. So negative 8 and plus 4 is a negative 4. Okay, and now I start the process again. So here coefficient is negative 4 divided by 1, so it's negative 4. And I can stop there because the rest is just going to be remainder. So the slant happens here, 2x minus 4, which is what it says here anyway.